Good day. How are you doing today? So today I'm going to show you how to use the chain rule to determine the first derivative of more complex functions. So let's get into it. So the chain rule states that if y is a function of u, so like y is equal to u, and u is a function of x, so u will be equal to x, then dy dx will be equal to dy du multiplied by du dx. So you can see now the du's, they cancel out, and then you just be left with dy dx. And that's the chain rule. So let's get into some examples. So the first example that I've given here is find the dy dx if y is equal to x cubed plus 3 to the power 7. So first thing that you do, let u be equal to the function that is in the bracket. That will be x cubed plus 3. And obviously, y will be equal to u to the power 7. Because remember now, x to the power 3 plus 3 is u. Therefore, y will be equal to u to the power 7. Then the next thing that you do, you have to differentiate this u function. And that du dx will be equal to 3x. And the derivative of a 3, you know, it's a 0. And also here, dy with respect to u will be equal to 7u to the power 6. And therefore, the dy dx will be equal to dy du multiplied by du dx. And in this case, that will be your dy du, it's 7u. And you want to replace, okay, not now. That will be 7u to the power 6 multiplied by du dx. And that is your 3x. And the next step that you want to do is to replace that u with x cubed plus 3. And that becomes 7 bracket x cubed plus 3 multiplied by 3x. Then there's power 6 here. And that's how you use the chain rule. Moving on to the next example. Find dy dx if y is equal to 6 over 2x squared plus 6x. Again, the first thing that you want to do, let that algebraic function, algebraic part be equal to u. So u is equal to 2x squared plus 6x. And y will be equal to 6 over u. And du dx will be equal to 4x plus a 6. And dy du will be equal to, so before you actually do the dy du, what you want to do, you don't want to differentiate when your variable is at the denominator. So you convert that y is equal to 6u to the power negative 1 using the laws of indices. And therefore, dy du will become negative 6 u to the power negative 2. Then dy dx will be equal to dy du multiplied by du dx. And that will be dy du, it's a negative 6 u to the power negative 2 multiplied by 4x plus 6. And you want to replace that u with 2x squared plus 6x. And that becomes negative 6 over u. So our u in this case is 2x squared plus 6x to the power 2 multiplied by 4x plus 6. And the final answer will be negative 6 bracket 4x plus 6 bracket over 2x squared plus 6x bracket squared. And that's how you solve that one. Then moving on to the next example. Find dy dx if y is equal to 9 over the square root of 8 minus x to the power 5. Again, let u be equal to 8 minus x to the power 5. and y will be equal to 9 over the square root of u. Then you differentiate your u with respect to x. Du dx will be equal to derivative of 8 is 0. Then that becomes negative 5x to the power 4. And before you differentiate this one, you want to convert that square root and to become also a numerator, that u. So that becomes 9u to the power negative half. Then you find your derivative. Dy du will be equal to, bring down the negative power half, so that will be negative 9 over 2. Then u to the power negative 3 over 2. Then the final step, dy dx will be equal to your dy du, which is minus 9 over 2 u to the power negative 3 over 2, multiplied by your du dx, which is minus 5 x to the power 4. And you want to replace now your u with 8 minus x, and that becomes minus 9 over 2 bracket 8 minus x to the power 5 to the power negative 3 over 2, then multiply by negative 5x to the power 4. And you can leave the answer like this, or you can simplify it further. Moving on to the last example. So example 4, find dy dx if y is equal to the fifth root of 5 plus 2x. Again, you let u be equal to 5 plus 2x. And your y will become 6 over the fifth root of u, which you can rewrite as 6 over u to the power a fifth, or you can rewrite as 6u to the power negative a fifth. Now, you find your du dx, which is equal to the derivative of 5 is a 0, then the derivative of 2x, that will be a 2. And you find also now the derivative of dy with respect to u, and that will be equal to, you bring down your power negative half, so that will be negative 6 over 5 u to the power negative a fifth minus 1, that will be negative 6 over 5. Then the last step is finding your dy dx. Remember, dy dx is equal to dy du multiplied by du dx. And that will be equal to, your dy du is that, and that will be negative 6 over 5 u to the power negative 6 over 5, multiplied by your du dx is this one, and that will be a 2. Therefore, the final answer will be negative 6 over 5. So you want to replace now your u again at the end with 5 plus 2x bracket to the power negative 6 over 5 times a 2, which you can simplify further to be negative 12 over 5 bracket 5 plus 2x to the power 6 over 5. And that's how you apply the chain rule in differentiating more complex function. Thank you. Hope to see you again.